All right, so we are in our second lesson of our unit. This is systems of equations. We are now going to start actually creating our equations and graphing them and seeing where their solution is. So here's what we're going to do. We're going to start off with our notes. I'm going to go through them, and then if I have time, I'll do another video for your homework. If not, you'll have to ask me questions in class. So we have our first equation here. We have two equations now. We have Mia starts with 2, then adds 5 each round, and then Jack starts with 18, then adds 3 each round. So we have our first one at 0. He started with 2, and then he's adding 5 each round. So it's 7, 12, 17, 22, 27, 32, 37, and then 42. Okay, so each round is adding, each one is adding 5. So our slope is 5. So we're adding 5 each time. Okay, so if you remember from last chapter when we were creating linear equations, we have our y equals and then our slope of 5x. And then our starting point is 2, so this is my, okay? So that's my, Jack starts with 18. So Jack is actually starting with more, but then he's not gonna add as much as my did each time. So we have adding 3 each time, so it's now 21. So 24, 27. So all I'm doing is adding 3 each time because that's what we said in the problem. We're adding 3 each time. So each time we're adding 3, 30, 33, 36, 39, 42. Okay. Oh, look at that. We can see that even in our graphs, we have the same point right here, 8 and 42. So when they're going to meet when x is 8, so I'm going to number these real quick. So 2, 4, 6, 8, 10. Okay. And then we're going to create our equation for Jack. So our starting point is 18, and our slope is 3 in this case. So Jack is y equals 3x plus 18. Okay, so on our graph, what does that look like? Well, we're starting at 2, so we're going to put a dot at 2, and then our slope is 5. So we are going to get to 1, and it should be 7. So 1, 7, 2, 12. 3, 17. So over 1, up 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Yep. And he's adding 5 each round. Okay, so this is 40, and you can even see 42, so 1, 2, and that is 8, 42. Okay, so then we're going to go back to Jack, and we're going to start off at 18. Luckily, Jack starts higher and adds 3 each round, so we're going to go over 1 and up 3. The slope is up 3 over 1, up 3 over 1, up 3 over 1. Okay, 1, 2, 3 over 1. 1, 2, 3 over 1. Getting closer and closer. 1, 2, 3 over 1, and then 1, 2, 3 over 1. And so they're meeting at this same point up there at 842. So that one's done. Our solution. So we wrote the equations, and then we're solving, and the solution is 842, because that's the one that matches up. 842 is where they cross. 842 is where they cross up here. Okay. All right. So number 2, we're going to do one more example similar to this. So I'm going to go a little quicker this time. So Andrew starts with 25. Okay. And then subtracts 3 each round. So we're going to now be subtracting. So 22. So we're subtracting 3 each time. Okay. Then we're going to go 19, 16, 13, 10, 7, 4, and 1. Okay, Chelsea starts with 5, and then adds 2 each round. So now we're going to go 7. So now we're adding 2. So we're 7, 9, 11, 13, 15, 17, 19, and 21. So each time we're just adding 2. We're adding 2. The other one we're subtracting 3. Well, you can notice that right in the middle, right here, 4, 13. So we can already predict on our graph when we graph this that this is where it's actually going to cross. Okay. All right. So now let's build our equation. Let's start with Andrew. Okay, Andrew, y equals, well, the slope is -3, so we're going to say -3, and we're starting at 25. And then Chelsea, our slope is +2, and we're starting at 5. Okay. All right, so now we can graph them, and I'm just going to count by 5s here, or count by 1. So 1, 2, 3, 4, 5. Going to put a dot, and I'm going to start with Chelsea here, and we're going to add 2 each time. So up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1. I can do it like this without having to look back at the graph because I'm looking at the slope, right? Your rise is 2, your run is 1, okay? And then up 2 over 1, up 2 over 1. Okay, that one's pretty straightforward. And it's going to go on forever like that. All right, so we're going to come back and do Andrew. We're going to start off at 25. So this is 5. And we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 is the very top here. So we have 0, 5, and then we have 0, 25. You notice that they're both 0. That's our starting point. And this one we're subtracting 3. So down 3 over 1. And we've got down 3 over 1. Down 3 over 1. Down 3 over 1. Look, this is right where they're crossing, right here. Okay, so down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And it's down 3 because we are subtracting 3 each time. So subtract 3 over 1. That's our slope. Okay, that's our slope. Our +2, that's our slope here. Okay. All right, so our solution is 413. Okay. All right, let's flip it over to the back side. Take a second, go ahead and pause it if you need to, and read your problem. Okay, so given the following 2 patterns below, draw figure 0 and figure 4 using a table and graph the equations and find out when the tile patterns have the same number of tiles. Okay, so again, that's a system of equations. The tile patterns just happen to be the way that we're representing the equations. So that's really what that's kind of what our system is here. We're looking for a pattern. We're looking for how many tiles they're adding each time. Okay, so our pattern here on pattern 1A, you can see that we're starting off with 2, and then we have 5 here, and 2, and then we have 5, and we've added 5 more, and then 2, and then we've added 5, 5, and 5. So each time we're adding a block of 5, right? So we're gonna go 5 here, 2 there to start with, and then we're gonna go 1, 2, 3, 4. I know my drawing skills are just fantastical. Okay, right there, right there. Okay, so now we have 22, so we have 5, 10, 15, 5, 10, 15, 20, plus 2, right? And then the last one, if we go the other way though, if we go backwards, we'd be subtracting 5 each time, so we'd be left with this figure 1 with just 2. Okay, so our slope in this case, m in this case, our slope equals +5. As we're going up, we're adding 5 each time, okay? Okay, so our second one, we have pattern 1A, our pattern 1B here, we might be adding in a different way. You can see that we're starting here, right? We have our little U shape, and then each time we're adding 2 blocks on top. Okay, so our next one is actually going to be 1 higher on each one, right? And then we're going to go down, over, down. Okay, I'm trying to be a little bit more precise on this one than I did the last one. Doing an okay job. Wouldn't say fantastic job, but okay. So our slope on this one is 2. So we're adding 2 each time. And then if we go back to our first series of the drawing, okay, we're going to be subtracting 2 from the second one to go backwards. Okay, so it's going to be 1. So we took off these top 2 going backwards. So we're adding 2 each time we go up. And if we're going backwards, we're going to be subtracting 2, right? So our slope on this one, or our rise over run, is 2. Okay. Okay, so so we're going to look at our graph here. And our starting point now is at 2. So for pattern 1A, we're starting at 2, right? And we're adding 5 each time. So it's 2, 7, 12, 17, 22, 27, 32, 37, 42. Okay. Our next one, we're starting at 14. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're starting at 14. And each time we're adding 2. So 16, 18, 20, 22, 24, 26, 28, and 30. Okay. All right, so our solving equations here, there's kind of a new tricky way that I'm going to show you how to solve this without graphing it, and we're going to do it both ways here. Okay, so our first equation, we're starting at 2. Okay, starting at 2. And then we are adding 5 each time. So 2 is our starting point, adding 5 each time. Our second equation, we are adding 2 each time. And we're starting at 14. Okay, so the algebraic way of solving this equation is substitution, which means that we can actually start using our equations to figure out the 2 points, okay? So I'm going to go through this one quickly, and I'll probably need to do some more examples in class, but just know that y and y are the same, and if they are the same, that means you can substitute an entire equation or entire part of the equation in for y. So if this whole thing equals y and y equals y, we can rewrite this as 5x plus 2 equals 2x plus 14. And now we can actually solve for x. So subtract 2x from both sides, okay, and we have 3x plus 2 equals 14. Subtract 2 from both sides, and we have 3x equals 12. Divide by 3, x equals 4. Okay, so I know I went through that pretty quickly, but we're going to do some more examples, and you'll have some time to practice it in class and rewind the video if you need to. Okay, so we have our x value of 4, but we're missing our y value, right? Well, the way you find the y values, you substitute it back into either equation. It doesn't matter which one you pick. I'm going to pick the second one, and I'm going to take 4, and I'm going to substitute it in for x. And we have y equals 8 plus 14, and we have y equals 22. Okay. So we have 4 and 22, right? Well, if we look back up at our 2 tables here, you'll notice that we have 422 right here, and we have 422 right here. Okay. There's the bell. I'm running out of time here. Okay. So our last one here, I'm gonna let you guys graph this in class, and then because we're running out of time and the video is getting a little bit long, I'll show you the key in class and you guys can verify that you got it right. All right, so good luck, and I'll see you.